Hi y'all, my name's Nathan. I'm a third year PhD student at the College of William and Mary.
Hi all, I'm Carlos. I'm last year PhD student at William and Mary.
Hi, this is Oscar Chaparro. I'm an assistant professor at William & Mary.
Hi everyone, my name is Kevin Moran and I'm an assistant professor at George Mason University.
Hi, my name is Denis Poshovanik, and I'm a professor of computer science at William and Mary.
And we wrote the paper It Takes Two to Tango, combining visual and textual information to detect video-based bug reports.
So let's rewind the clock to the days of traditional text-based bug reports. In these days, bugs would be described in natural language and contain very important information such as the expected and observed behavior, as well as the steps to reproduce the bug. Additionally, a wealth of research has gone into detecting duplicate bug reports. These systems can help save developers time by aggregating groups of similar reports so that they can be properly assigned to developers and reduce wasted effort. However, just like the software crisis of the 60s, bug reports are going through their own crises. In that, let's be honest, they are often boring and tedious to write. Also, when they're poorly written, it can make it difficult to detect duplicates. If only there was a better way. Enter video-based bug reports to save the day. They cover two of the three bases of bug reports in that they already contain the observed behavior and the steps to reproduce the bug in a graphical nature. But this isn't all sunshine and rainbows. All of those previous techniques that we just discussed for detecting duplicates won't work out of the box on videos. Differentiating videos that are duplicates can be much harder and slower than compared to text-based bug reports. And this is because there may be a lot of unnecessary information appearing in the video, and navigating around videos to check to see if one is a duplicate of another can be really cumbersome.
Therefore, we came up with Tango, a tool for detecting video-based bug reports. Tango takes as input a new video-based bug report, as well as a corpus of existing video-based bug reports. It then outputs a ranked list of the most similar bug reports in the corpus compared to the new bug report. This allows a developer to quickly determine if a new bug report is a duplicate by reviewing the top results from Tango. Tango has two main parts, a visual part and a textual part. Additionally, the visual part of Tango has two parts, one that considers the order of the video and one that does not. However, for the sake of time and because it's really hard to explain, I'm going to skip the order part. Also because it just didn't really work well. Now, let's start by examining the visual part of Tango. The goal of the visual part of Tango is to extract visual information from a video to determine its similarity to another. To do this, we use an approach called SimClear to train a neural network to extract visual information from each frame in a video. This neural network is trained by first taking random screenshots of mobile apps and generating augmentations of them. These augmentations include things like random crops, rotations, changing the color, grayscaling the screenshots, etc. For this work, we use the awesome RICO dataset containing 66,000 screenshots from a wide variety of apps. Augmentations, as well as the original screenshot, are then passed through a feature extractor model, specifically a ResNet-based model, which takes as input an image and generates a vector representation of it. The model is then taught to make a vector representation of a screenshot and its augmentations close together while also making them far apart from other screenshots in the dataset. This allows the model to capture meaningful semantic information that exists in the screenshots. Now, we could take this model and generate vector representations for each frame in a video and try to use them directly to determine similarity between two videos. However, since videos can be different lengths, we need a better way to represent videos in a common way. We could probably take the average of all the vectors in a video to represent it, but we'd probably lose a lot of information. So instead, we convert these representations into visual words. That way we can use standard information retrieval techniques that have been done in the past. To do this conversion, we take the trained model and pass in a random subset of the RICO dataset through it to generate a vector representation of each of them. Next, we apply the k-means algorithm to these vectors to discover the different clusters that arise. The centroids of these clusters are considered the visual words for our approach. With these clusters, we can now take some screenshot, pass it through our model to get its semantic vector representation, and then assign it to the closest visual word. We then do this for each frame in a given video, which we get using FFmpeg to generate a bag of visual words. We then use the term frequencies and document frequencies, which we generate using the RICO dataset, in order to perform the standard information retrieval technique TF-IDF. And with this TF-IDF representation, we can now compute the similarity between two videos. And here's Oscar with the textual part of Tango.
Textual Tango first uses ocular character recognition, or OCR, to extract any text that appears in the screens depicted in the video. This text is used to create textual documents. Tango then takes each textual document as a bag of words. We use the Lucene framework to index all the textual documents for fast processing. Tango represents the textual documents using the TF-IDF approach via Lucene. Then it uses Lucene's scoring function, which is based on cosine similarity to compute the textual similarity between documents. In other words, between videos. Videos with more similar text will have higher textual similarity, therefore higher chances to depict the same bug. Once Tango computes the two similarity scores, one based on visual information and one based on textual information, Tango combines these scores by smacking them together using a linear combination to produce a final similarity score. Based on this combined similarity score, Tango produces a ranked list of videos from the corpus that are likely to depict the same bug of the query video.
To evaluate Tango, we created 4 different research questions. For research questions 1 and 3, we use standard information retrieval metrics such as MRR, mean average position, and hit rate to measure the performance of Tango. For our study, we used 6 open source applications and had 13 participants, including 3 authors of the paper, record multiple bug reports having duplicate videos to evaluate Tango on. This ended up totaling 180 videos. Here is an overview of different configurations of Tango and their performance in some of the metrics we calculated. From this table, and also because I have highlighted it in bright purple, you can see that the combined configuration of Tango performed the best. Specifically, I want to highlight Tango's performance for hit at 1 and hit at 2, which shows that a majority of the time a developer can expect to find duplicate bug reports in the first result returned by Tango. However, if you look closely at the performance, you will see that the Tango's configuration that only uses visual information is actually extremely close to the combined performance. Additionally, on a majority of the apps, the textual Tango configuration actually outcompetes the visual configuration. However, this is not the case for 2 apps, codenamed Time and Talk. From here, you can see that the textual Tango configuration performs extremely poorly, and that actually decreases the performance of the combined Tango configuration.
We analyzed the vocabulary overlap of duplicates and non-duplicate videos in our data. First, we measured the average amount of vocabulary shared between each pair of duplicate videos. Then we measured the average amount of vocabulary shared between each pair of non-duplicate videos. And we computed the difference between these measurements, which are normalized. As seen in this screen, we found that for Time and Talk, this difference is smaller than for the other apps. And this is one of the reasons why Textual Tango has a hard time detecting duplicates. We defined a threshold for the difference of vocabulary overlap to determine if Visual Tango and Textual Tango should be combined, or if Visual Tango should be used only. If we apply this approach, we are able to increase the performance. Tango would recommend a correct duplicate video as the first and second candidate in 67% and 83% of the cases, respectively. For our final research question, we estimated how much time Tango would save programmers in finding duplicates. We defined a set of duplicate detection tasks where participants had to determine if a video-based bug report is a duplicate of other videos given to them in random order. We measured their average time to complete this task, and based on that, we estimated the time saved had they used Tango. We found that Tango can save over half of the time it takes to find a duplicate bug report compared to the videos being inspected randomly.
So, in conclusion, here's all the awesome stuff we did. We created Tango, a tool for helping developers find duplicate video-based bug reports. We evaluated Tango and found out it's kinda awesome. Specifically, it can save developers over half their time finding duplicates. Finally, because we're awesome, we released all of the code and data in a replication package for your viewing pleasure. In this package, you'll find detailed information on the code and data, as well as how it's organized. You'll also find information about replicating our results, and a CLI version of Tango for testing out Tango on your own data. Well, that's going to do it for this presentation. Thank you very much for sitting through it.
Welcome back to the most fun parallel live session. Just letting you know that you're in the right room. So, in case after the third presentation you kind of feel the Zoom fatigue setting in, that also applies to Clouder, I want to invite you to take a deep breath. Exhale, let it go with a sigh. Ah, yeah. I know sound effects are the best, right? Take another one. Ah, let it go. Cool. Take a sip of water. And yes, lots of applause. We have two of the authors here, Kevin and Oscar. I think this was a fabulous video presentation. I got to watch all of them ahead of time. And now you get to ask them a ton of cool questions because now you're really awake again, right? So give us your questions in the chat because otherwise I got a whole list ready for them. You have 7.5 seconds, maybe. Okay, I get to ask first. So, you pointed out a lot of interesting future work. What's cooking right now?
Yeah, so maybe I can start, and then Oscar, you can fill in any gaps that I miss. So I think there's a few interesting things actually that kind of happened after we published this. So one development that's actually kind of interesting is that GitHub has now added kind of native support in their issue trackers for videos and GIFs. So people can, directly upload these these artifacts, natively into GitHub now. So I think we're going to continue to actually see more and more proliferation of this type of graphical software artifact. So we're looking forward to seeing potentially opportunities for mining new data and seeing how this evolves in the future. And in addition to that, I think there's actually some really interesting things we can do in terms of looking at how we can automatically tune some of the parameters of the approach for different types of applications. So for example, if we have applications that share a lot of textual similarity across their screens, or that share certain types of visual similarity with different types of themes, we may be able to detect that before we run our approach on it and tune some of the parameters that we have in an automated way to hopefully have the approach kind of adapt to those different types of situations. So those are just some things that we're, kind of starting to think about and work on, as potential extensions to this work.
Cool, thank you. Carlos, Oscar, is there something that you would like to add to that?
Yeah, I guess, well, another thing that, because videos will become more prevalent in bug reports, as Kevin pointed out, because of GitHub and more developments in issue trackers. One thing that we want to focus on in the future is because bug reports will contain a mix of visual content, textual content, right? And all this information may be useful for developers for trying to fix the bug, but not only for that, for trying to detect if there are duplicates of the same videos, the same bugs and so on. So we plan to extend our approach to consider this mix of information. Right now, we focus only on video content, video-based content, but the reality tells us that in the future, there will be more mixed information.
Good. Okay. Thank you. We also got a couple of questions in the chat rolling in. First of all, some compliments. Great video. Super great work. And then Sridhar is asking, did you observe visual or textual information having more priority in certain bug reports? For example, for this bug report, we might consider visual information more and less text info, and vice versa for another bug report.
Well, maybe I can start answering the question. So we didn't observe particular bug reports where that situation occurred, but we definitely observed applications like set of bug reports that where the visual information was more important or the textual information was more important. As we showed in the video, we did some analysis on why in certain cases the textual-based information doesn't work that well, right? And we found that between bugs, there's very similar text that that confuses the textual part of the model. So, but this is something that we need to explore more. We need to do some more analysis on this issue. If there are, I anticipate that some bug reports will have this situation in which textual part will be more important, or the visual part will be more important. Karen, do you want to add something?
Yeah, I think Oscar is exactly right. You know, we did notice that mostly on a per app basis, there are certain features that are going to be more informative for duplicate detection. In some cases, that might be visual. In some cases, that might be textual. It depends on really the amount of kind of like vocabulary agreement in the text, you know, across different screens of an application. If there's a lot of very similar text, that's going to be a less useful feature to identify, you know, kind of diverging video-based bug reports. And likewise for visual patterns. If we see applications that maintain a really consistent kind of visual mode throughout different screens, then that might not be as useful as, you know, very kind of diverse textual information across screens. So it's very app dependent. And I think, you know, there are ways that we could kind of tune the approach given some kind of upfront analysis on the app itself before we start processing bug reports.
Mm-hmm. Okay, thank you. There's a question that came in that you may have already answered in part. Rashmi is asking, among the apps that you studied, is there a particular category that is more amenable to video reports? Like, you just mentioned something about patterns, but I'm not sure you covered the question already. Or is there another aspect to it?
Yeah, I can start with this one maybe. So for our study, we didn't take bug reports, you know, directly from open source apps. We weren't studying kind of patterns that were naturally occurring, but we did conduct a user study where we had users, you know, basically take an app, record a video for a given bug, and we did this across, you know, a wide range of bug reports.
Mm-hmm.
So I think this is actually kind of a difficult question to answer because I think it's hard to tell from, you know, from our analysis, like, is it more, for example, is it more effective to report a bug via a video as opposed to, you know, via textual information or opposed to some other modality? But I think that's a really interesting question to ask in the future. And, you know, particularly as GitHub is, you know, adding support for these types of, you know, videos, maybe app stores add support for this in the future. That could be a really interesting, you know, type of mining-based study that you could do, is seeing, you know, okay, are there any patterns in how people report bugs, you know, across different types of applications, or maybe even the maturity of the application? There's, I think, a lot of different aspects you could look at there.
Mm-hmm. Yes. Yep. It sounds like there is a lot of future work piling up. Lots of interesting questions to look at. So I see we got you covered for ICSI for the next 5 years until that topic is completely taken care of. And I'm glad we got you on the team for that. Yeah, so we have 1 minute and 20 seconds left in this session. And as they tend to go quickly, I want to point out to everyone that there is a discussion room for afterwards. And we got 44 people in here, so it would be lovely to see many of you in the discussion room. And the link for that one will pop up as soon as the official event ends. Then you have this extra link, this little green window popping up that says, go to the discussion room, click here, and then poof, you're gone. And you will be in the discussion room with all the fun authors of this session. So let's take a moment to thank everybody who's been participating here. I want to thank you a lot for all the cool questions that came in the chat. I want to thank you, Kevin and Oscar, for playing Q&A with me and for having some good answers and for ingesting some new food for thought, which we hope we will see transformed into a fantastic new paper to be submitted in August. Stay tuned.
Thank you.
Lovely. So all the applause is for you. I love it when these things fly across the screen. I'm just waiting for them to come out of my display and go further beyond. So anyways, see you in the discussion room. Thanks, everyone. Bye for now.